Welcome everyone, and thank you for joining us in what is going to be a masterclass on the SenseGlove Unity software development kit. My name is Shehryar Siraj, and I am a marketeer here at SenseGlove, and I will be your moderator today. In a moment, we will have Max Lammers here. Max is our lead software developer, and he is going to be explaining the updates in the latest Unity SDK. Before we begin, I would like to add a few words on how we will be dealing with your privacy. If in the future we decide to upload this video, we will take the appropriate measures to anonymize your identity so that in any future reproductions of this video, no one can know that no one will be able to find your names. You are also, of course, welcome to join this video with a random Google account. And as long as you are using the same link which we sent you via email, you should be able to join this video. Now, without further ado, let's have Max with us. Hi, Max. How are you doing?
Hi, Cher. I'm doing fine.
All right, Max. I leave the floor to you.
Awesome. Thank you very much for the introduction. Hello, my name is Max Lammers. As you can probably tell by the little link below my name, I am the lead software developer here at SenseGlove, and today I'll be walking you through some of the new features that we have added to our SenseGlove Unity SDK, as well as some little sneak peeks into the future. Well, let's get started right away. I'll be covering first some basic concepts of our Unity SDK for those of you who may not yet be familiar with how we've set everything up. Then I'll go into the nitty-gritty of all the features, and we'll follow up with a live demo of said features. And after which I'll give you a little teaser as to what we've been working on, what is next, and finally I'll leave the floor to you guys as well for some questions and answers. If you have any questions during the presentation, feel free to drop them down. And you'll be greeted by a SenseGlove folder. It contains a number of scripts, number of prefabs, and I'll be going over some of the architecture of how we make things work. First things first, the SenseGlove hardware script is a component that you can add into your scene, and you can already talk to your SenseGlove. In this component, you can check whether you want to talk to a right hand, left hand, or any SenseGlove. And you can use this as a reference in your script or in your events to access any kind of glove data, ranging from all the individual positions of the exoskeleton to full-fledged hand pose in coordinates that are working with Unity. It is also your main interface to send force and vibrotactile feedback in the form of sending brake or buzz commands. You can also, this is also your interface to turn those on and off as your application desires. We use this particular hardware to drive our animation, as well as detection of certain things. One of those being feedback. If you have an object in your Unity project and you add a SenseGlove material component to it, script, it will then be detected by our hand prefabs. Your fingers, as they touch an object, will register colliders that have this SenseGlove material attached. And based on the distance of how far you squeeze into one of these colliders, it changes the force that is applied to the fingers. So it increases up to the max force over a max force distance. You can tweak these variables in the inspector to assign different material properties to different objects in your scene. So as this implies, if you mark something with a SenseGlove material, you can feel it. Now the same goes for grabbing and manipulating objects. If you can feel something, you might also want to pick it up. In that case, We have our SenseGlove interactable scripts. We have SenseGlove grab scripts, which are the ones that transform the position and joint angles of your hand into grabbing and releasing of objects. They respond to any script that has, for example, a grabbable attached to it. And you can either use these built-in SenseGlove grabbable drawers, doors interactions, or if you have your own way of handling different kinds of interactions, you can switch over and only add a little component called the detection grab components, and that will cause the grab script to fire events when you grab and when you release objects. So based on those events, you can then tell your own system that something is being grabbed or released and handle it appropriately. Now, with the basics out of the way, connection to hardware, connection to feedback, and connection to manipulation, we can move on to the good stuff, the new features, and I'll be showing them off here. You'll be able to see my Unity editor screen, and if need be, the positional camera. So let's get started. First things first, we've added a calibration scene. This will allow for a guided scenario, which will teach you how to calibrate one of our solvers for the SenseGlove. By taking an open hand and a fist as a pose, we can then interpolate between those two gestures to calculate your joint angles. These joint angles are stored on your disk so that other applications using the SenseGlove SDK can also access them. That means calibration, you only need to do calibration 1, and after which your other VR or simulations or telerobotics applications can use that same file. I'll switch over to my Unity editor and I'll give you a little live demo of what that looks like. So in our SenseGlove plugin, this little folder right here, this is what you get when you import it. You'll find a scene called SenseGlove Calibration. Double click that, run the scene, and we've got ourselves a connection to a SenseGlove. Right now, this is what I'm wearing in my hand. And I'll just be giving a quick overview. As you can see, I can move around my hand. You can see what, and I can, you'll see some instructions in the top left of the scene. In this case, it wants you to open your hand, so mimic what the gray hand button or the space button. So, bam, we're done. Next, it wants me to make a fist. So, I make a fist with my SenseGlove, press spacebar again, or calibrate the next one, and that results in the following joint angles. It now knows what my open hand and what my fist looks like, and it will interpolate between those values. Now, of course, if at any point you are not satisfied with your interpolation, for example, I did make a full fist. This doesn't look very nice if my thumb is up. I can calibrate my thumb adduction to set it to a slightly different value. This is a bit too high. There we go. And now I've got myself much better calibration. Now, once I'm done, I can hit save if any changes were made, or when I exit out of it and changes were detected. This is now all stored on disk, and I can access it for the future demo.
Sorry, Max.
Yes.
Could you move the glove a bit to your left so we can see it properly?
My left? Yes. Right
Your
over here?
left.
Of course.
Yep.
All right. Let's move on to a different feature. Now I'm going to go to back to here. Because there have been some minor changes. Right now, the SenseGlove is compatible with Bluetooth, which means we've added a few more commands to our communications protocol to make sure that your connections are properly detected and closed off. We now also have documentation for all scripts automatically generated using Doxygen, which you can find now zipped in the folder. It is a navigatable and searchable database that will tell you exactly what sort of functions, what sort of parameters these scripts are, and what they do, along with a bit of description. If you're curious, for example, what this script does, you can see how it derives, especially useful when you're looking at some of our interactions. You can see how they sort of flow. So if you have any questions regarding the sort code itself, you can find it in our documentation folder. Now, as you may have noticed from the documentation folder, we have changed some of the naming of our scripts. Usually we had them called SenseGlove underscore something. That's fairly long to type every time. To save everyone some time, we concatenated now SG underscore will get you an immediate link to all the SenseGlove scripts in your project. And that's not all, of course, as we've also changed the way we handle our hand model. Now, in the old prefab that we used for SenseGlove to handle animation, feedback, etc., it was all part of the same blue hand model that you may have seen if you've worked with our SDK before. You had to set it as a child of, for example, this tracker here to be able to move it, and you would need to know the correct offsets of said tracker. We had some scripts that had dual functions, and we had say all the individual grabbing and feedback collision. It was all integrated into the hand model, which made it more difficult to switch it out for another model. If you wanted to have, for example, not our blue hand, but a glove or an alien hand or a robot hand, whatever suits your simulation, you would have to painstakingly dive deep into the roots of the hand and do it all yourself. Now, we've changed it up by splitting everything up in different layers. Our tracked hand, that's now your main interface for the tracking of the hand and offsets. We have a little game object that's responsible that actually contains the 3D hand, our blue hand model, for example, and tells the other scripts which joints to use for animation or tracking. We have an animation component or layer that is responsible for actually moving the fingers. So if you have your own tracking system for the fingers, you can simply turn that game object off, and you can the animation will you're free to use your own animation. We have a layer for feedback, which is responsible for detecting your SenseGlove materials and sending the data back to the hardware. We have a grabbing component or layer that is responsible for handling the pickup and release detection of the SenseGlove. And finally, we have two new features. We have our rigid body layer, where you can add rigid bodies that mimic your hand to be able to push objects away from you. If you turn that off, for example, your hand would be a ghost floating through different objects. In a similar but not quite the same layer, we have the physics tracking. Now, imagine that the rigid body allows you to push objects away. The physics tracking layer allows objects to push you away. If you have things like walls, containers, drawers that you don't want your user to get into, the physics tracking layer are actually a series of colliders that mimic the hand that stop it from moving through non-trigger colliders. Now, what does that look like if I go back into the Unity engine and I start up an empty scene? We now have prefabs for the SenseGlove. It's not technically an empty scene. I have added some little props in here and there to showcase a little bit more than just a void. But now, if I've got my SenseGlove hand, drag and drop it in here, you can see all the different layers represented as different game objects inside of the prefab. Now you can see your hand model, animation, all containing the different components responsible for each element. And as different game objects, you can very easily turn off, for example, the feedback if you're the one who's handling that. If you don't want your hand to be able to push stuff away, you can simply turn off the rigid body layer and disable that functionality entirely. Now, the cool thing about this new prefab, if I drag it in, it's asking for a tracked object. I've already got a Vive tracker set up here, the thing on the back of my hand. if I say you're following this object, and this is a Vive tracker, it will automatically set up the correct layers. I'm just going to show that right now. If I have this hand in front of me right here, see if I can wake up the old Vive here. There we go. I can now turn this on. It's gone to sleep. It already automatically has the right offsets for a Vive tracker, so that my hand in VR is actually where I think it is. A little white dot you can see here is just a placeholder to show where the actual Vive tracker is. Bonk.
Sorry, Max, just
Yes.
a quick question. Let's say we already have made scenes in the past with the SenseGlove, of course using the older SDK, and we now wanted to bring in these new separated components of the SenseGlove. What would we have to do to be able to compartmentalize or control each element of the glove?
If you want to have access to our latest SDK, and you already have our SenseGlove integrated into your project, it's a similar procedure to re-importing like a new SteamVR plugin. Best practice there is to go to your SenseGlove folder and delete it. Remove it from your scene, so we don't get any dual scripts. We have moved some folders around, and then to re-import the Unity package anew. Now that's going to create some conflicts in any scripts that you might have. For example, your scripts are relying on certain names, but as we mentioned before, we have changed some of these names. Fortunately, Visual Studio or most coding environments have a very nice find and replace function. And I'm actually going to skip ahead and I'm going to go to one of these upgrade guides. It's also available on our GitHub Wikipedia page.
Okay.
So in any script that uses our SDK, you simply find and replace anything SenseGlove underscore related, and you replace that with SG underscore.
Sure.
That will solve all your code conflicts. And again, to get the hands back in, you simply delete your old prefabs, drag in the new ones, and assign the right offsets or the right tracked objects.
And I think we can leave the link in the description below for anyone who wants to see this, the scripts that need to be changed. Please continue, Max.
All right. Yeah. So it's as simple as dragging the prefab in. It doesn't need to be childed. It doesn't need to be anywhere. Should you still want to use the old way and say I want to have a child, just simply drag it into your Vive tracker and set the tracking hardware to custom. It will then just take its local position, rotation, the way you're used to. There we go. I'm just going to use this new way, so I like it a little bit better. And well, as you can see, of course, within the prefab, these are the different layers, everything responsible for grabbing, for picking up stuff. And if I link it to one of my quick demo scripts, I can actually toggle the colliders, and we'll show them in a bit, because I may have mentioned before that we've had something called physics tracking, and I'll actually go a little bit into detail about what I mean by that. So if your virtual hand if your real hand can pass through virtual objects, no problem. It has no idea that it's there. However, you want the virtual hand to stay behind when it hits a wall or something that you don't want the hand to pass through. So while the real hand's here, the physics tracking layer using the Unity's built-in NVIDIA PhysX engine keeps the hand squarely at the entrance, and also, at the entry point of your real hand. And if you move the hand back out, the virtual hand will simply appear back at the original position. I'll give you a little bit of a live demo of that as well. Go back into this scene. Now what I've done is I've added our little prefab. I just need to say we're using a Vive tracker, and we want to have the physics tracking method. So this tracking method defaults just has your hand pass through everything, all automatically done for you. Physics-based enables our physics tracking layer, and if you want to do your own tracking, just disable our scripts. Right now for the physics tracking, there's a whole bunch of components here. Let me just load this up. There we go. I need to minimize this real quick. Yeah, because I want to show you what those tracking colliders look like. Put this back up. Okay, right. What I've done now is I've told this little script to enable the debug mode. Now these blue colliders that you see here, these are responsible for collision. So these blue colliders, if I try to pass through this table, these blue colliders are what stays behind. So what this allows us to do is allows us to rub across the surface, even if our real hands, or if you see the little white dot bouncing up and down, that's my real hand Vive tracker, tries to pass through. You can also accidentally, well, it is possible definitely to get stuck under the table, for example. In case that happens, if the real position gets way too far away from the virtual hand, it will pop back into existence. Oh, this one's not actually part of our hand, this is just something you can pick up. So this way, you're able to give a immersive, let's say, environment. So we actually combine that with what we like to call impact vibrations. So if you have a hand like this one that is not allowed to bump through the table, we add something called impact vibrations. So in the feedback layer, the collider is responsible for getting feedback to your fingers. There's something called impact feedback. You can enable that, disable that for each finger, set a cooldown and a minimum speed that they need to fly at before we trigger them. What's happening now is every time I'm slamming my hand on the table, I get a different intensity of vibration depending on how hard I hit the table. And I can tweak those parameters to make it more sensitive or less sensitive. To feel something very light as soon as I tap something, it's all possible. And of course, if you don't want it, simply hit the check mark and it's all gone. Right. Oh. Those are, well, the main new features. So when I go back into this scene, if I get up real quick, give a little live demo of how it all looks combined. We have these physics tracking layer colliders, which means our hand stays behind on the table. And of course we have a different layer that's responsible for grasping objects and one for feeling. So you can still interact with these SenseGlove objects the way you normally would, with the added benefit of having rigid bodies to push them around. We've increased the range of our grab detection, so it's much more stable, much more consistent. And so the rigid bodies make it a bit more difficult. But with this, we're now able to have much more immersive simulations than we've ever had before. But of course, that's not where things stop for SenseGlove. We're actually hard at work at improving our current SDK and also implementing several new features. And for the upcoming quarters, we'll be hard at work at releasing at least one update to our Unity SDK that features some of the things that we've been working on in-house. One of those things is that we're revising our hardware communication, the way we talk to our glove. We're using a C# backbone at the moment, and we're transferring over to C++, which actually opens up compatibility with Linux and other systems. We're going to make some improvements to the hand tracking algorithms, and the calibration will likely change to reflect that. And calibration will, at that point, still be a part of a guided scene or executable. And finally, we're going to refactor just the way we handle the hardware, so that we're able to actually support different kinds of tracking and force feedback gloves in the future. And for our after that, we're going to continue improving the way we handle, manipulate objects, the way we can override tracking like we do with the physics tracking. And we are actually working on more complex manipulation of objects with two hands that would have much more weird and intricate it opens up much more weird and intricate manipulations, such as two-handed tools, or things like rivet guns, or just like two-handed bars, or machines that require you to press two safety switches at the same time, for example. So that's pretty much what we have been working on and what we're working towards. We'll continue to update you with at the very least every quarter, with new features. And of course, if you guys are if you have any features that you would like to see happening in the SenseGlove SDK, we're more than open to discuss any changes to better fit the needs of our clients, of course. And yeah, that would be just your master class on how to get started with our new Unity SDK, showing off some of the new features. I'd like to thank you very much for the attention.
All right, great. Well, thanks a lot, Max. I certainly learned a lot of new things, even though I'm here every day. If our viewers have any further questions, I would invite you to comment it below, and we can try and answer them right now. Of course, if you have some detailed questions, you can contact us via the contact page on our website. The link is in the description. And also, if you have any technical issues that you might be facing in your coding, you can of course ask that on our GitHub page, where you can also see the answers to previous problems faced. And of course, do hit the bell notification if you would like to be able to keep up with our updates, at least the ones which we record on video. And with that, I believe, I think I can thank Max on behalf of our viewers. Thank you very much for taking out your time and explaining the new software development kit.
You're very welcome.
And of course, I'd like to thank the viewers. And just, it's been my pleasure being the moderator for this video. And until next time, I guess we will be in touch with you. Thank you. Yep, my apologies. I was a bit quick in closing the stream, but we do have some questions here. I will ask Max. Is there an Unreal SDK coming up anytime soon?
So we are at work actually at integrating our new C++ backend into the Unreal Engine as well. It is quite a lot different from what we're used to with Unity. We're working with blueprints rather than scripting, working with actors instead of game objects. So we're still trying to wrap our head around this, but we're aiming for possible release the end of Q3, maybe Q4, for an Unreal SDK. Starting out with the basics, much like we did with the Unity engine, and building it out from there. You'll definitely see some of the features, if not all the features, that we have built into the Unity engine eventually make its way to an Unreal SDK as well.
Ah, great. Okay, I have another one.
All right.
Well, could you be a bit more detailed on how you can calculate the force feedback?
Sure, yes. I actually prepared for this. If you'll excuse me and head over to my little presenter view. Yes, so the way we calculate force feedback right now, forgive my terrible doodles, but the feedback levels on the force, it's now currently based on how far you are inside of the collider. If I take, that can be any kind of collider, like a mesh collider or a sphere collider, for example, this cup. As soon as I touch this cup, I'm registering the entry points to this cup, and if I'm moving closer or deeper inside of the cup, I can sort of project that distance. So basically, if this cup is my sphere, and I go 1 centimeter inside of the cup, I can use that as a input for my SenseGlove material. We sort of, you can see on one of my sides here, the deeper you go into the collider, the more we ramp up the force. That's where the max force parameter is used. That's the maximum force this material gives. And it gives that as soon as it reaches the max force distance. In this case, I'm in slightly in the way, but in this little example, the max force is at 100%, and the maximum force distance is at 2 centimeters. It's in meters, because for Unity we're using absolute units. So if you're 2 centimeters into the material, that means you get the maximum amount of force, and that's currently only done with a ramp function. And one of the smaller details we're also working on is improving the way this is handled. Up to recently, we have been able to determine these nice profiles using Unity's animation curve system, and that's what also will allow you to, based on the distance inside of a collider, determine by yourself what the profile would be. So you can make an object that sort of is very soft until you reach a certain point, and it's really hard, and then if you keep on squeezing, at some point it drops back down. It will work with sort of a keyframe system. If I can show you one of the, I'll show you one of the feedback layers. So right now this is how we've chosen to implement the impact system. So right now, if I, similar to this, if I reach my minimum impact speed and up to a maximum input impact speed, I can determine a curve. So right now I have it set that if I reach my minimum impact speed, there's just a very little force feedback. And if I reach the maximum at 1 meter per second, it reaches the maximum vibration that this finger can give. Unity's curves allow you to choose different preset profiles, and you can also add key points in between. So if this is the final strength of my material, and let's say I want to add something in between. Okay, first it ramps up really hard, then it goes up to a maximum force, and then somewhere here, let's say it breaks at this point, and I want to add another key. There we go. Right. So right now I can also flatten those off. So right now I've got a material that starts at soft until it reaches a certain strength. You can keep going and squeezing, and it actually ramps up a little bit, but when you pass beyond a certain distance, in this case, it gives out, much like a real sort of elastically deformating material. That's what we're aiming to use for the next update as well, in terms of your force feedback. And yeah, again, the calculation is based on the distance of your virtual hand inside of the collider. That's the answer for a little bit more detail.
All right, great. I have another question. What devices do support Bluetooth?
What devices do support Bluetooth? Are you talking about SenseGlove devices, or are you talking what devices in the world are supporting Bluetooth?
Well, I was just dictating right as I see it. I believe what they're trying to ask is if the SenseGlove supports Bluetooth.
I see.
Or if we can connect the SenseGlove via Bluetooth, I'm guessing.
Right now, the SenseGlove hardware as it is not compatible with Bluetooth, but we are hard at work at we're currently in the quality control stage of building our own wireless kit, which would be a small little box that allows this SenseGlove with a short USB cable to be wireless. You may have seen it at some of our 5G fairs, but we have been hard at work, and part of this update also is to ensure compatibility with that wireless kit. That would mean that our SenseGlove becomes available with any device that is compatible with Bluetooth, which includes but is not limited to phones, standalone headsets, and personal computers.
All right. Well, we got a bit more detail on that. I believe what they're asking is something related to the versions. Which Bluetooth versions can the device support?
That's a good question. That would be a little bit outside of my personal knowledge, because I'm not one of the people who is developing the wireless kit.
Okay.
But if I recall correctly, it would be a Bluetooth 4.
Sure, and I think we can get a bit more detail from our hardware department, and I could send out an email in general so we can know down to which Bluetooth version we can get support.
Very good. And once our wireless kit releases, I'm 100% positive that there will be a specifications page on things like battery life and frequency bands, and indeed Bluetooth version would be a good one to add to that. Thank you very much.
I agree. That would be helpful. That's a good question. I have another one. Does the force feedback just work with specific materials which has soft collider layers? And that's soft in quotation marks.
I see what you mean. Like there would be multiple layers of collision based on the touching of objects. In this version of the SDK, No, I don't think that's not the case. So each finger only registers the first material that it touches. It is possible to, let's say in our next version, it would be possible to, using the animation curve, add these layers yourself. If it is a requested popular feature, I can think of making the fingers, like the colliders for the fingers, a bit smarter, so they can register multiple collision or multiple colliders, and then simply send back the force that is, simply send back the strongest force. That is definitely also possible.
All right.
Some interesting, interesting ideas here.
All right.
I'd
Sure.
like to
Sure.
talk about it. Sorry.
Well, everything for me is interesting here because I'm the marketeer, and everything here is new information. Well, insightful information on the glove for me. I have another question. As the calibration was done performing different gestures, would it be possible for the SDK to recognize these gestures later on?
Yes, so recognizing gestures right now is still a bit limited. I actually used to recognize not gestures, but if the hand was standing still until a certain time. A gesture recognition API is definitely something that I would see in the foreseeable future. If not the version of Q4 2020, then in Q1 2021. As you will see that as a gesture layer added to the hand prefab. So the main challenge with that is to provide a Unity UI/plugin that would more intuitively let you work with these gestures. And I'm talking maybe an integration with the SteamVR or OpenVR like gesture input system, or building our own one from scratch and somehow making you able to link that to actions within your scene. Like that's the biggest challenge there. We have some code lying around for gesture recognition, but it's mainly static. So if one pose you can recognize, but let's say dynamic gestures such as the HoloLens's bloom gesture, ready tap ready. Those ones are still need to be implemented. That's still on the way.
Okay. Oh, that's
and
good
actually,
to know.
if you're a C# C++ developer out there who would love to get his hands on that sort of tech, or would like to help out with that, we do have actually some positions open for exactly these kinds of internship or graduation projects here at SenseGlove.
Well, yeah, if you'd like to know more about these internship opportunities, I believe you can register for our newsletter online, and we frequently update the list of vacancies. Max, I had a question for you.
All right.
You referred to building alien hands. I'm curious, now that we have a modularized sort of components of the glove in the SDK, would it be possible for us to disable, for example, a few fingers so I can pretend what it's like to be an alien with, I guess, 3 fingers?
Well, the moment, let's say our animation layer, you can either have all the fingers animated by the SenseGlove or not at all. However, it does rely on some hand model information that tells it which joints to animate. So actually, if you only give it the joints for, let's say, those 3 fingers, and you don't give it the information on how to animate the other fingers, it won't do it. It simply skips those fingers. So if you have an alien hand with 3 fingers, you only need to assign those 3 fingers to the hand model information, and the animation will only move those 3 fingers.
So like the 2 remaining fingers would just be sticking out.
If you have a hand with 5 fingers and you want to maybe simulate what it would be like for someone who's missing 2 fingers, yes, they would be static. They would still stay behind because there's no animation being applied. However, in Unity, if you have a hand model like ours, you can simply set the scale of those root bones to 0 and just make them disappear. It looks a bit weird, but that's a very easy way to implement that.
Okay.
You might have to delete maybe some colliders in the that specifically refer to those fingers if you don't want to feel any vibration on them still.
Certainly.
But because of the nature of the system, you can just delete those, and it should work itself out.
Sure. I think we'll wait a few more moments for maybe some more questions.
Right.
I have another question. Is it possible to save the different calibration profiles? I think that could be very useful for our clients who are where lots of people are using the SenseGlove for the simulation. Of course, everyone has different hand sizes. We know that the designing of the SenseGlove was such that it can fit most of the sizes, but when it comes to calibration, where do the files save? Is it possible to name those files? Can we have those same people return and use the SenseGlove without having to go through the gesture calibration?
So with the current SDK, mainly focused on actually storing stuff on disk. So right now it only saves the latest data in your My Documents /SenseGlove /calibration. You'll find your little text files containing information for the left and right hands, which are the serialized classes, if you will. Now you can just rename those to a certain name. However, it will be looking for something like SG-L and SG-R for the left and right hand specifically.
Okay,
there is a roundabout way of doing it now.
Go ahead.
But the thing is, we are currently revising our calibration, our kinematic algorithms that actually do the solving. So the data that is stored might change. So that's why for now we focused on actually storing it, and the next step would indeed be would be good to add different profiles, if that is something that people desire. That is, I definitely can see that happening, even possibly for a next update. It should be easy to add it in, but it should then also be easy for developers or users to switch between profiles. I think definitely that's something we can introduce relatively quickly.
Okay, that's great. That's a good question, and of course, great suggestion for us. All right, Max. I don't see any more questions. I certainly enjoyed this conversation. We got some really good questions in here, and I do see an opportunity for some future questions, possibly in the comment sections, or just in general.
Yeah.
I believe we should end this call then. Yeah.
Yeah, if there
What do you
are
agree?
any questions, feel free to reach out to us at our via our website or info@senseglove.com. If you have any technical specific software related questions, you can use the built-in ticketing system of our GitHub. The link will be somewhere down below to go to our Unity plugin GitHub, which also contains a number of Wikipedia pages on how to do stuff. How to integrate new hand models, how to send stuff back and forth. Because a lot of it has changed, I'm still in the middle of revising documentation, but it will be updated as this week progresses to reflect some of the things that I've said here today. If you at any point have missed part of my explanation, if it's going a bit too fast, I'm known to ramble sometimes. I think this video will become available on our SenseGlove channel as well.
That is the idea. After we, of course, do some editing and make sure we are good on the privacy end. And of course, I believe our viewers can expect more videos like this. All right then. Thank you everyone for watching. Thank you again, Max,
Thank you,
for your time. And yeah, we will be in touch. Have a nice day, everyone.
Thanks. Have a nice day, everyone, and stay safe.
Yep. Take care.
Take us away, Maestro.